I want to swap two variables, typically of the same data type. Let's picture it in my favorite analogy, which, if you haven't guessed by now, is food. I have a plate of pizza and I have a plate of a sandwich. How do I exchange them if I cannot hold them in my hand? The answer is another plate. You move the pizza to a third plate, you move the sandwich to the first plate, and then you move the pizza to the second plate. And I'm done. Great success. Aside from normal variables, this applies to values within lists as well. I have a list of 1, 2, 3, 4, 5, and I want to swap 1 and 2 since they're in the wrong positions. How can I do that? I save 1 in another variable, and then I move it in the following steps. X goes to y goes to x, and z goes to y, just like in the pizza sandwich example. But what if I want to be super diligent, right? And not even create a third variable like z to swap the variables to save on time and space complexity, like we discussed in our algorithmic complexity chapter all the way back. This is where our XOR logic comes in handy. And this is how it goes. So first, you XOR x and y, and then you store the result in x. Then you XOR x and y again, but you store the result in y. And then you XOR x and y and store the result in x again. And voila, see what you got. We don't need an additional variable to swap the values anymore. And this is what you call an optimized way of doing the same swapping process. And in code, this is how we implement the function.